All right, 3.9, translating parabolas. Objective students will be able to shift, scale, and reflect parabolas. So here's the deal. We're looking at the parabola or a quadratic function, and we're mainly looking at it in vertex form right now. And this is what it looks like in vertex form right here. We got y, and then we're going to have some a value. This is usually 1, but it could be other values. It could be something greater than 1 or something less than 1. X minus h, we've done this before. We've seen this before where the h is actually a horizontal shift. It shifts it left and right, but it's really important. See how there's a minus sign? So that means x minus 1 actually means that it shifts it to the right one. So we do the opposite of what's inside the parentheses. I talk about that over here. So you always do the opposite of what's inside the parentheses. The k on the outside, that is the same. So if this were to say plus 1, it would shift it up 1. So this shifts it vertically, and this shifts it horizontally. And inside, it's the opposite of whatever our h value is. The a value is something we're going to talk about on the back, but the a value actually causes it to causes your parabola to either get skinnier or to get wider. And we'll see some examples of that on the back and in class. Okay, so let's go ahead and just kind of chat about some of these questions here. If we look at example 1, it says, how can we shift function f to get g? Essentially, we're saying, hey, we started with f here, and we want to do something to it. We want to move it in a way so that it would be the same as g of x. Well, the mother function that we call it is x squared, right? So that's the typical just y equals x squared function. And if you were to subtract 5 inside, well, that's like making the h value 5. Remember, we do the opposite of this. So this is negative 5, so that means we're actually going to move it in a positive direction 5 units. Well, positive along the horizontal would mean that we're moving it 5 units to the right. And that's it. We would just say 5 units to the right. And that's it. That's all we have to do there. And so if we were actually manipulating a graph, we would just drag it 5 units to the right. So practice 1, very similar. I want you to try this now. Think about it. You're starting with the mother function x squared, and then it's being manipulated somehow so that it looks like g of x, which is x plus 3 squared. So you're going to pause the video and just give this a try. Think about how that would shift the function. Okay, so hopefully you thought about it and you saw that, well, it's the opposite of positive 3. So my h value would be negative 3. Over here, the h value was positive 5. But over here, it's negative 3. So that means this shifts 3. That looks like shifts barely. 3 units to the left. And that's it. It would shift 3 units to the left. So this whole graph, which I have over here, would just slide over and start right there instead. Okay, and now we're going to talk about the k value. So now, what if they're just adjusting the k value? So now, how did I go from x squared to x squared plus 3? Now the 3 is on the outside, so this is like this k value, and we know the k value does a vertical shift, and on the outside the signs don't switch. It's not an opposite sign. So on the inside it's the opposite, on the outside it's exactly the same. So if this is plus 3, it literally just means we're moving it up 3. So shift up 3 units. Pretty straightforward, so go ahead and see if you could try practice number 2 on your own. Okay, so let's talk about this basic function. Now, when I say the a value, I'm talking about the basic form that we had out in front. Let me just show you. We had this, where there's an a value out there. And there might be some h, or h might just be 0, and there might be some k, or k might just be 0. But a is typically 1. But a changes the scale of something. So let's just read through this. As stated above, the a value either causes the graph to get skinnier or wider. Okay, skinnier or wider. This is because if the value is large, so if the a value is large, then the function grows taller faster. Okay, so like imagine if this was like 10x squared. Okay, well then it's going to grow 10 times as fast. So that's going to make the graph, you could think about that visually here. If your typical function, looks something like this, and then you had something else that was y equals 10x squared, well, you could anticipate it to do something like this. And maybe it doesn't seem to make sense as to why it would be skinnier and skinnier, but really the reason why it's skinnier is because now instead of just growing at this simple rate, it's growing 10 times faster. So it's getting higher faster. So that's what makes it appear skinnier. But the real thing that's going on here is it's just getting higher faster. And then in the same way, if the same value is small, like a fraction, then it will grow taller slower, causing it to look wider. So now let's think about what if it was, I'll do it in green, what if it was something like y equals 1/4 x squared? Well, now it's going to grow a fourth of the speed, and so the graph's going to look wider and wider. So that's kind of why those numbers do that to it. It scales it. It either makes it grow faster and faster or slower and slower, depending on whether that number is greater than 1 or less than 1. So the a value is what scales a function vertically. See how it scales it to either grow faster or grow slower. All right. So for example, the function 2x squared will go twice as fast as our mother function x squared, and so it is scaled vertically by a factor of 2. So that's some language that you might see in some problems, and we'll see them in just a second. Now, to get it to reflect, when the a value is negative, it reflects downward, causing the function to grow in a negative direction. So let's do one more here. Let's say now I was just going to do, I'll do this in yellow. Hopefully this will show up. This is what it would look like if I just did negative x squared. Because it's still growing the same rate, right? I didn't change the value. It's just negative 1, where here it was positive 1. So it should look exactly like this blue curve here, but just flipped upside down, because now it's growing in a negative direction. Those are all the ways that the a value can change the scale of the graph, or kind of the direction of the graph. So we got example 3 here. It says the parabola y equals x squared is scaled vertically by a factor of 1/3. So that literally just means you're multiplying it by a third. It's going to grow a third of the rate. So what is the equation of the new parabola? Well, it's really pretty simple. It's just, instead of y equals x squared, it would just be y equals a third of x squared. So now it'll grow a third fast. A third is fast. All right, so for practice 3, I want you to just try it on your own. There's 2 things you got to think about here, but it's really not tricky. Just give it a shot and then check back when you're ready to check your work. All right, so hopefully you first saw that it's a factor of 4, so we're going to multiply by 4, and it's reflected downwards. So that tells me if it's reflected downwards, it's going to be negative, and we're still going to do a scale factor of 4. So this is negative 4x squared. We're just multiplying it by negative 4. This would cause this graph to, if this is your base function, your graph here would get skinnier and skinnier, and it would reflect down. And just, I'll talk about example 3 real quick too. If you had this as your base function, when I say base function or mother function, I mean the typical just y equals x squared. This guy is going to be, it's not going to grow quite as fast, so it's going to be a little wider. It's going to grow a third as fast. See? So that's what they're looking for the equations, but also this is just giving you a little visual to help you understand what's happening to the function. A third, like it's growing by a factor of a third, so it grows slower. Here it's growing by a factor of 4, so it's going to grow faster, but it's also flipping downwards, so it's growing in a negative direction. All right, hopefully you get some good understanding of that to try some of these last skills from this chapter. I'll see you guys on the next video.